Hi, today we are going to be looking at a question involving differentiation. In particular, it is dealing with finding the second derivative of a curve that is defined parametrically. The question says a curve is given parametrically as x equals e to the negative 2t, y equals e to the 3t. Find d squared y over dx squared in terms of x. To start, we look again at the parametric form of the curve, which is given as x equals e to the negative 2t, y equals e to the 3t. Actually, the curve is said to be given parametrically because x and y are defined in terms of another parameter, t. And to differentiate, then we need to use the chain rule in order to get the first derivative of y with respect to x. And the formula says dy dx equals dy dt times dt dx. So this is in accordance with the chain rule. But then we have to rewrite this formula in a more useful form, the form that we can easily handle when differentiating. The fact that dy dt times dt dx is the same as dy dt divided by dx dt. This is simply because dx dt is the reciprocal of dt dx, and we can easily find dx dt from the way the x has been defined in terms of t in the equation. And we also need to look at the fact that the x and the y have been defined parametrically in terms of an exponential function. It is also important that we see how to differentiate exponential functions. D over dx of e to the f of x equals f prime of x e to the f of x. So when differentiating an exponential function with base e, we simply differentiate the index or the power of the function and then multiply by the function to get the derivative of that function. So we can now start with the differential. The differential of y with respect to x would be equal to dy dt divided by dx dt. Now y is given as e to the 3t and x is given as e to the negative 2t. So dy dt divided by dx dt will then be d over dt of e to the 3t divided by d over dt of e to the negative 2t. And from there we proceed to do the differentials. So e to the 3t differentiated will give 3e to the 3t. Again, the differential of 3t with respect to t is 3, and then it has to multiply the function in order to get the derivative with respect to t as already outlined above. And the differential of e to the negative 2t with respect to t should give negative 2e to the negative 2t. So the differential of the power, the differential of negative 2t will give negative 2, then we multiply by the function to have the derivative of x with respect to t. When we now divide the expressions at the numerator and at the denominator, we get negative 3 over 2 e to the 3t minus negative 2t. Remember, when you are dividing indices, you subtract the powers, and at the end dy dx should be equal to negative 3 over 2 e to the 5t. So this dy dx is in terms of t. We recall again that we are being asked to find the second derivative in terms of x, and normally to find the second derivative of y with respect to x, we need to first find the first derivative of y with respect to x, namely dy dx, and that is what we have just obtained. And so to get now the second derivative, we have to differentiate dy dx with respect to x, so that we have that d squared y over dx squared equals d over dx of dy dx. And we note that dy dx that we are supposed to differentiate with respect to x is not in terms of x. You can see the expression that we had, it is in terms of t. So we would have to rely again on the chain rule to be able to differentiate that. Since it is in terms of t, we have to start by differentiating with respect to t and then multiply by dt dx according to the chain rule. So in the next step, then we get d squared y over dx squared equals d over dt of negative 3 over 2 e to the 5t. That's the first derivative that was in terms of t. So we'll first differentiate with respect to t and then multiply the result by the reciprocal of dt dx, which should give 1 over dx dt, and we had dx dt up as negative 2 e to the negative 2t. And from here now we proceed to simplify by noting that at the numerator the coefficient of e to the 5t would be negative 3 times 5, and at the denominator we have 2 times negative 2. So the negatives will cancel, and then we have at the numerator 3 times 5 divided by 2 times 2 at the denominator. Then we have e to the 5t divided by e to the negative t. Again, applying the rules of indices, we are dividing two indices that have the same base, and so we can subtract the powers to arrive the result, which is now e to the 5t minus negative 2t. So simplifying further, we see that d squared y over dx squared equals 15 all over 4 e to the 7t. 3 times 5 will be 15, 2 times 2 would be 4, and then e to the 5t minus negative 2t. Negative becomes positive, so the exponent of that e should be 5t plus 2t, which gives 7t. And now we have had d squared y over dx squared in terms of t, but the question said we should express it in terms of x, and so we have to express then d squared y over dx squared in terms of x in the next step. To do that, we have to recall again that x is given parametrically as e to the negative 2t. So bringing our second derivative that we just had, we then have to be strategic in order to express it in terms of x. To do that, we take the second derivative that is given as 15 all over 4 e to the 7t, and make sure that the exponent negative 2t that is appearing in the expression for x in terms of t appears in that function, and the only thing you can do is to send out 7, then introduce negative 2, and then divide by negative 2 in order for the expression to remain the same. So what we have simply done is sending 7 out of the exponent of e, and then introducing negative 2, and then dividing by negative half, so that the negative 2 that we have introduced would not change the expression that we are seeking to simplify. And so in this form now we can see that the bracket has e to the negative 2t, which corresponds to x, so that in the next step now we replace it to have d squared y over dx squared equals 15 all over 4 x to the power negative 7 over 2. You can see that the bracket has been replaced by x, while negative 7 over 2 remains the power of that exponent, as x now is replacing the exponent. From here again we can apply one of the laws of indices, which says x to the negative 7 over 2 is the same as 1 all over x to the 7 over 2. So when you reciprocate an index number, you simply change the sign of the power, and that is what has happened with x as we are reciprocating in this step. So finally d squared y over dx squared in terms of x will be 15 all over 4 x to the power 7 over 2, and we can further simplify by looking at 4x to the power 7 over 2. We note that x to the power 7 over 2 is the same as x to the half raised to the power 7, and x to the half is the same as the square root of x. So we can also express the answer in the simplest form as d squared y over the x squared equals 15 all over 4 into the root of x raised to the power 7. Now there is an alternative method in that we can first find the Cartesian equation of the curve before differentiating, and it will be simpler depending on whether we can manipulate that easily. So again we remind ourselves that the curve is given parametrically as x equals e to the negative 2t, y equals e to the 3t. In order to express these parametric equations in Cartesian form, I would simply have to make t the subject in one of the equations and then replace it in the other equation. Preferably making t in the equation having x and then substituting it in the equation having y. But then we can still do a manipulation simply by putting the equation of y, which is supposed to be y equals e to the 3t, and modifying it to contain e to the negative 2t, which is x. So we start again just like the manipulation we did previously in the other method. We send the power 3 out of the exponent of e, then introduce negative 2 as the coefficient of t, and then neutralize that negative 2 that we have introduced by multiplying the outer power by negative half. And so we would have that y equals e to the negative 2t raised to the power negative 3 over 2. If you multiply negative 2t by negative 3 over 2, you would get back your e to the 3t, the original y function that we're dealing with. And so we can now replace the exponent in the brackets e to the negative 2t, which corresponds to x, to have that y equals x to the power negative 3 over 2. This other power, negative 3 over 2, will now be the power of x, as the exponent e to the negative 2t has been replaced by x. So now y is in terms of x exclusively, and we can now find the derivative of y with respect to x, so that we can proceed to have the second derivative. So to have the first derivative, we simply differentiate dy dx equals, we use the power rule whereby we multiply the base x by the power and then subtract 1 from the power. So we have negative 3 over 2 x to the power negative 3 over 2 minus 1. This would simplify to give negative 3 over 2 x to the power negative 5 over 2, because negative 3 over 2 minus 1 gives negative 5 over 2. And this is the first derivative of y with respect to x. Now to have the second derivative, we have to note that d squared y over dx squared equals d over dx of dy dx, and that should then be d over dx of the first derivative that we are just from getting, negative 3 over 2 x to the negative 5 over 2. Proceeding to differentiate, we have to multiply again the coefficient of x by the power of x as we are differentiating using the power rule, so that we get negative 3 over 2 times negative 5 over 2 x to the negative 5 over 2 minus 1. That will give us 15 over 4 x to the negative 7 over 2, which again, using the laws of indices, when you reciprocate an index, the sign of the power will change. So we get the result as 15 all over 4x raised to the power 7 over 2. And from there, then we can conclude again that d squared y over dx squared equals 15 all over 4 the root of x raised to the power 7, the same result that we had previously in the other method. Please, if you are new in this channel, consider subscribing and activating the notification bell so that you don't miss any of our videos, because we post very interesting videos that teach a lot.